Okay, so triangle ABC is the image of triangle ABC, or A prime, B prime, C prime is the image of triangle ABC after translation of 2 units right and 3 units up. Is the triangle ABC congruent to triangle A prime, B prime, C prime? Explain why. So this should be an easy question. If you translate an object, it does not change size or orientation, so it should be congruent. So some things you can say are, is it congruence transformation that preserves size? You could say it's a rigid motion. I would say, and I like to be very like formal in these things. So let's see. They ask, is it congruent? So you need to answer yes or no. So yes, triangle ABC is congruent to triangle A prime, B prime, C prime after a translation because translations are rigid motions that preserve angle measure, and side length. Be thorough. Don't say, yes, congruence transformation. I don't think that's enough. The state's very specific about that. Okay? Pretty easy question, but sometimes if you didn't say enough, you didn't get enough points. So triangle ABC and point D, 1, 2 are graphed on the set of axes below. Graph and label the image after a dilation of scale factor 2 centered at point D. Now you guys know that drawing lines on this thing is very difficult, so I'm going to try to use these. I always try. I know. But I'm going to go from point D, see, through B. I can't do that. Try again. Draw. I'm going to try one more time and then I'll call it. Sorry. From point D. Nope. Not doing it. Okay. You should construct or draw lines from the center of dilation through the points. Again, I'm so sorry about these lines. They're really hard to draw straight on here. So we're going to dilate it by a scale factor of 2, D2. From D to B, you go up 1, 2, 3 over 1 unit. So after a dilation, that should happen 2 times. So I should be going up 3 over 1, up 3, 1, 2, 3 over 1. So B prime will be here. D to A, I go down 1 to the left, 1, 2, 3. So down 1 to the left, 1, 2, 3. Again, my lines are terrible. You'll draw nice lines using your compass and straight edge. D to C, I go down 1, 2, 3 over 1, 2, 3. So I do that again. 1, 2, 3, 1, 2, 3. So off. Okay. So there is your new triangle. So sorry. I swear that my answer key looks way better than this. I swear I used a straight edge. Okay, I want you to see that. I used a straight edge like a normal person. Okay, so it doesn't say to state the coordinates. It's just graph and label the image. So I labeled the A prime, B prime, C prime after a dilation centered, and I showed my I showed my lines of dilation. You should have them labeled. You will have them solid. I'm just trying really hard there. Okay. Sorry. All right, quadrilateral bike and golf. Bike golf. That doesn't sound safe. So describe a sequence of transformation that maps the quadrilateral onto the quadrilateral. Okay. I'm almost done with this. It's so fabulous. Okay. Well, here's the one thing that if you weren't paying attention, you didn't notice. Bike and golf, which means B ends up matching with G, right? So B, this kite, it's a kite. I don't know if you study kites. This picture has to flop, right? It has to flip. So that means there's going to be a reflection involved. I need a reflection of some sort. And then it's moved over. So I'm going to use reflection and translation. So it just depends on how you wanted to do this. You could reflect first through the y-axis. 1, 2, 1, 2. So K is here. 1, 2, 3, 4. B is here. 2, 3, 4, 5, 6, 7, 8. You could have done that, right? Reflect through the y-axis first. Sorry, I'm just trying to sketch this for you. And then you would just translate up 1, 2, 3, 4, 5, right? You could also translate up 5 and then reflect. So you have a couple of ways you can say that down here. I would say, I think I would reflect first. I did it differently here. Reflect, oh, I should, reflect, B-I-K-E, bike, over the y-axis, translate B prime, I prime, K prime, E prime, up 5 units. And I would have my work on here because this is going to help me justify, right? So this would be B prime, I prime, K prime, oh, nope, E prime, sorry, I prime. And then your work is shown there. The thing with reflections is you have to say where you reflected over. So make sure you don't just say like reflect and translate. You've got to be specific. So say reflected over the y-axis, translated up 5 units. Be very specific there. In the diagram below, oh, it's funny. A kid asked me about this question literally 5 minutes before they walked into the test. So I hope that young man got this right because he was, wait, which one do I use when? So in the diagram below, we have secants, RST, RQP, drawn at point R, intersect at circle O, la, la, la. R to S, here we go, label. R to S is 6, S to T is 4, so that means the whole thing is 10. R to P, the whole thing is 15. We're trying to find R to Q, which I will call X. So the formula or method you have to know here is whole exterior is equal to whole exterior. So the whole outside, the first segment, R to T, the secant, is 10. The exterior piece is 6. The whole length of secant RP is 15. The exterior length is what I'm looking for, X. So 10 times 6 is 60, equals 15X. Divide by 15. And what's that? 4 is equal to X. So RQ equals 4. You label it in the picture, so it should be fine, but I always like to, you know, be good about showing my work here. All right, 29 is a construction. So median. A median, definition of median is that it's going to be the middle of side AC from vertex B. Okay? So I'm going to guess, so middle of a side AC, so here to here, from B. So it's going to go through this triangle, okay? You would have to construct a perpendicular bisector on AC. So you measure from A to more than halfway. So I would probably, to here. And you create, this just stinks. I hate this. It just stinks. So, well, I'm not even going to try. You construct a perpendicular bisector. You measure more than halfway, so you draw these lines, and then from C, you keep that distance. You draw those lines. You see where they intersect. Yours is much more beautiful than mine. And it should intersect, and you draw the perpendicular bisector from your intersections here and here. We're going to pretend that's my perpendicular bisector. Yeah? Then you draw the median from B. Let's see if I can do it on here, if it's not in a graph. From B to the center there. That was terrible. So I'll erase it. Okay. I will just draw in purple. From B to that midpoint on AC, and you should label it, or you have to label it median. I'm glad you liked that, or I hope you liked it. Okay, so Sky says that the two triangles below are congruent. Margaret says that the two triangles are similar. Are Sky and Margaret both correct? Explain why. First thing I would notice is that these are two right triangles. And if you know the Pythagorean triples, this is pretty easy. If you have two legs of 5 and 12, you should know that the hypotenuse is 13. And if you have a hypotenuse of 13 and a leg of 5, you should know that the second side is 12. So these two triangles are congruent because they have the same sides, right? Side, side, side. Or they are hypotenuse, leg, whatever you want to do there. So Sky says they're congruent. He's right. All congruent triangles have congruent angles, so angle, angle, similarity as well. So they're actually both correct. So what I would say here is say all the things. Be very thorough. I started with Sky. And I said down here, I'm going to label these A and B. The hypotenuse of triangle A is 13 centimeters. The second leg of triangle B is 12 centimeters. Sky is correct that the triangles are congruent because they have 3 congruent sides. Done. Then I would go on to say, Margaret is also correct that the triangles are similar because all congruent triangles are similar triangles. Okay? Be thorough in your explanations. I think that's what we learned there with the points awarded or not awarded. Okay, so Randy's basketball is in the shape of a sphere with a maximum circumference of 29.5 inches. Determine and state the volume of the basketball to the nearest cubic inch. We've got two things mentioned here. we have two vocabulary words, I guess, circumference and volume. So if you've ever, held a basketball, that the fattest part in the center, right, is in the center, and like up here would have a smaller circumference. So we need to know radius to figure out volume. The volume of a sphere. Let's go back here for our formula sheet. Dang it. Volume of a sphere is 4/3 pi r cubed. See it down here? 4/3 pi r cubed. So the only thing we need to know is the radius of this sphere. So volume equals 4/3 pi r cubed. But they don't give me the radius, they give me the circumference. And I know the circumference formula, or the better circumference formula, is 2 pi r. So 29.5 is equal to 2 pi r. So I want to find the r. I'm going to divide by 2 pi. And I'm going to get a value for r. Now, I've got to use my calculator. I'm going to show you, I would store in this case. So 2 pi, Control, divide. 29, is that 0.5, divided by 2 pi is that number. I am going to store that for r. Okay, you'll see why in a second. I'm going to write it down though. 4.69507082121. I think I copied that right down. Okay, down right, sorry. And I'm going to write store. Because now I'm going to go over here to find the volume. Volume equals 4/3 pi r cubed, right? I stored r, so I don't have to rewrite that number. I'm just going to write r. So I'm going to go to my calculator. Assuming you just wrote the same thing twice. I know, it's fancy. And I'm just going to type it in. So Control divide. 4/3 pi times r cubed. 433.525. So volume equals 433.525903652 inches cubed. I'm going to go back up here. It said to the nearest cubic inch. Nearest cubic inch. So I want to end here, so I look at this one. 5 tells me to raise 434 inches cubed. Fabulous. All right. Let's move on to the next one. Part 3s, here we go. So these now are worth 4 points, and so they should be a little bit more work, right? In triangle ABC, the vertices with coordinates -1, -1, 4, 0, 0, 4 prove that triangle ABC is an isosceles triangle, but not an equilateral triangle. The use of the set of axes below is optional. Okay, so I would guess that most of you plotted your points and drew your triangle. That would be smart. My experience tells me state a fact, do the math, make a conclusion. And since it says 2 different things, I'm going to have 2 different facts, 2 different sets of math, 2 different conclusions. But that's a lot of things. Hush. That's all I'm going to say about that is hush. So, in an isosceles triangle, two sides are congruent. Okay? Oh, come on, period. Just stay there. So I'm going to do the math. So in order to find congruent sides, I'm going to use the distance formula to find the length of each of these. So AB is equal to the square root, and I'm going to do, let's see, -1 minus 4 squared plus -1 minus 0 squared. And just trust me that that turns out to be 26 underneath there. B to C is the square root of 4 minus 0 squared plus 0 minus 4 squared is equal to the square root of 32. Now notice I'm not getting like crazy decimals here. I'm putting just the underneath into the calculator to get the value, and I can compare them that way. Then I'm going to go A to C is equal to the square root of -1 minus 0 squared plus -1 minus 4 squared equals square root of 26. So what that gives me is that, so AB is congruent to AC, therefore triangle ABC is an isosceles triangle, right? Then I say, in an equilateral triangle, all three sides are congruent. From that, I know BC is not equal to AC. Yeah? Therefore, triangle ABC is not equilateral. Now, many of you might use the Pythagorean theorem to do these sides, and you'll use the graph. I just use the distance formula. I would also recommend writing down the distance formula. I did not do that. Distance is equal to x2 minus x1 squared plus y2 minus y1 squared. Oh, this is one of my favorite questions, and that is not sarcasm. It's because I used to teach this in Algebra 2 trig, but then they took all the trig away from me. Okay, and they just left the Algebra 2. The map of a campground is shown below. Campsite C for station F, supply station S, along a straight path. The path of the supply tower T is perpendicular to the path from the supply station to the campsite. The length of path FS is 400. The angle formed by TF and FS is 72. The angle formed by path TC and path CS is 55. Yikes. Okay. Determine and state to the nearest foot the distance from the campsite to the tower. A lot of things going on here. Campsite to the tower is... Whoa, I just threw that all on the floor. Oh gosh, I'm going to have to get that in a minute. All right, so we are looking for this length here. So most of you will call this length X, and that's fine. There are several ways to do this. I am going to say that I usually do find the middle and do law of sines twice. That's typically how I do this. It just depends on how your teacher did it. They might tell you to find something in a right triangle and then use the other right triangle. That's fine. So I'm going to just do law of sines twice because I think it's easiest. And if you can always do the same thing, I don't like to change the rules a lot. So determine and state to the nearest foot the distance from the campsite to the tower. Well, that X is in this big triangle, and I don't know any whole side lengths in the big triangle. What I do know is in this mini right triangle, I know a whole side, and that's that base. So your options in this question are to find the middle, or this hypotenuse of the smaller triangle, and then use law of sines to find the hypotenuse of the bigger triangle, or you could find the height of this triangle, which also turns out to be the height of the big triangle, right? So you don't have to use law of sines. So that part is up to you. The very first thing I would suggest doing, though, is labeling all of the angles. So if I could possibly zoom in again. And it won't let me. Awesome. Maybe if I put the pen down, it will let me. There we go. Okay. So let me, oh gosh, now I'm sorry, guys. This is not not easy to do. So I would fill in all of the angles. Right next to here, 72 and 108 make a linear pair, so we know that's 108 degrees. In this yellow triangle, if that's 72 and that's 90, that means that this angle is 18 degrees. And in this weird triangle, we've got 108 and 55, meaning that this angle is 17 degrees. So just using some of angles in a triangle is 180. So I'm going to find this middle side, and I always like to call it M for middle. That just makes sense to my brain. So I'm going to do my work here instead of down there so I can see the picture a little bit better. So the law of sines, and the law of sines, I don't know if they do it right side up or upside down. So I'm going to say I always do the sine of the angle over the side is equal to the sine of the angle over the side. So the only side I have is this 400. The angle across from it is 18. So the sine of 18 degrees over 400 is equal to, I want to find M, so I'm going to put him down here. The angle across from M is 90. That's that 90 degree angle. So sine of 90. Cross multiply, it's your favorite thing to do in math. So M times the sine of 18 degrees is equal to 400 times the sine of 90 degrees. To get M by itself, we divide by sine of 18 degrees. So I'm going to get a crazy whacked out decimal for that. Now, if your calculator is in radians, so look up here, is it in degrees? If it's in radians, all you would need to do is make sure you put a degree symbol next to whatever you have. So 400 times sine, was it 90? You would just have to do degrees, which I think is here. Yeah, you would have to use that degree symbol over there. Divided by sine of 18, and you would have to use a degree symbol. Oh, jeez. Sorry, I forgot his calculator's wacky. I think I have to press Control Enter. There we go. Now, M is going to be that, so I'm going to actually store that. Store for M so that it remembers that, and I'm going to write that down. So M is 1294.427191. Do not round. You cannot round halfway through a question. Do not round. Write that whole stinking decimal down. I'm just going to write store so I can use it in a second. Now I'm going to go to the awkward triangle. So in the awkward triangle, where the X is, we don't know this side. We know this side, though, and I've stored it. So I want to know what X is. And across from side X is an angle of 108. So sine of 108 degrees over X is equal to sine of what angle is across from M? Across from M is 55 degrees. Sine of 55 degrees. Now I've stored M, and it's right there, so I could even put an arrow there saying, hey, I did this. So I'm going to cross multiply. hello, where's my marker? There it is. M times the sine of 108, remember M is a number, is equal to x times the sine of 55. So to find x, I just divide by the sine of 55 degrees. And now I have to go to my calculator again. So m sine of 108 divided by sine of 55. Control divide. M times the sine of 108 divided by the sine of 55. 1502.86. So x equals 1502.86314,177. Let's find out what the rounding directions say. To the nearest foot. So that would mean I want to round to here, so I look here. 8 tells me to raise. So 1503 feet. 1,503 feet. Okay, fabulous. All right, let's go here. All right, so this question, I know that these can be a little bit daunting, blah, blah. This isn't so bad in terms of these volume questions. You know we've seen worse. Uh-oh, what did I just do? You know we've seen worse. So this was sort of a gift, right? All of the coffee. Okay, let me gather myself here. So Shay has recently begun kickboxing. Yes, that's excellent. Kickboxing is a really, really good workout, and it lets you release some stress and maybe some anger. And purchase training equipment as modeled by the diagram below. The total weight of the bag, pole, and unfilled base is 270 pounds. Okay. The cylindrical base is 18 inches tall with a diameter of 20 inches. So we've got pounds and inches. All right. The dry sand used to fill the base weighs 95.6 pounds per cubic foot. All of a sudden we have feet. So I would suggest before you go any further, because this is in feet, down here, let's see what they say. To the nearest pound, determine and state the total weight of the base filled to 85% capacity. So I am going to convert 18 inches and 20 inches to feet. So we know there's 12 inches in a foot. 18 divided by 12 is 1.5 feet. 20 divided by 12 doesn't work out real nice. So I'm going to leave it as 5/3 feet. I'm scared of fractions. Let it be. You're going to use a calculator. It's fine. Okay? It's fine. So I converted those first. To the nearest pound, you're going to figure out the total weight of the training equipment. Well, the total weight is going to be the weight of the equipment, so the unfilled, plus the sand, right? Weight of sand, but times, not the whole base, only 85%, so 0.85 volume of the base. Sorry, my notation is not great there. So we know that the unfilled is 270 pounds. We now have to figure out the volume of the base filled with sand, right? So down here, as always, they give us diameter instead of radius. So the radius, if the whole 20 inches is 5/3 feet, and this is 1.5 feet, then that means that the radius is half of 5/3. Oh. So I'm just going to show you. Oh, come on. Yeah, no, I clicked on you 4 times. Let me doc B this. Doc B. 5/3. Holy smokes, this is making me crazy. 5/3 divided by 2 is 5/6. That's an ugly number, by the way. 5/6. I develop a small lisp when I say that. 5/6 of a foot. Okay. So the volume of this base, volume of a cylinder. Again, we need our formula sheet, right? Volume of a cylinder. Pi r squared h. Pi r squared h. So, go back here. Oh, go back here. Volume of a cylinder is pi r squared h. Pi. The radius is 5/6 squared. The height is 1.5 feet, right? We converted to feet. So we're going to need our calculator for that for sure. So pi times 5/6. Dang it, I forgot my parentheses. Use parentheses, they're fabulous. Squared times the height, which is 1.5. Okay, there's your volume. Let's write that down, 3.27. So volume equals 3.2729234749. But we're only going to fill that 85%. So 85% of 3.2729234749 is equal to, so times 0.85, 2.781, so write out the whole decimal, 2.78161849,537. Okay, so that's 85% of that. But we need to do the weight of sand. So our total weight is equal to the unfilled, which was 270 pounds, plus the weight of the sand. What was the weight of the sand? It said 95.46 pounds per cubic foot. This is feet cubed, by the way. So 95.46 pounds times 2.78161849,537 cubic feet. I'm going to type that right into my calculator. So 270 plus 95.46 times that number. So now we have 535.53. Where are we rounding to? Nearest pound. So total weight is equal to 535.533301,568. Round to the nearest pound, so total weight is equal to, we want to round to here, so we look here, that tells me to raise 536 pounds. Not a bad volume question, considering the ones we have seen, right? All right, then we go on to this proof. It's actually pretty great proof. I'm going to kind of talk you through some of the ways you can do it. I'm going to do one of the ways. So lots of different ways you can do this. First way you could have done it is you can prove that those two side triangles are congruent. And then you can use corresponding parts and properties of parallelograms. You can establish that the inside is like BEDF is a parallelogram with a right angle, so it's a rectangle. So there's a couple of different ways. I'm just going to pick one of the ways and do it, I guess. So, because I can't do it 6 ways, we'd be here forever. So let's see. We have statements. I like that this little line showed up. Statement, reason, and since we know my lines are not very straight, I'm not even gonna, oh, maybe this time this will work, right? Oh, look at that. Isn't that nice for once? Okay. Oh, first thing to tell us is that ABCD is a parallelogram. So, where am I? Hello, where? Oh, there I am. 1. ABCD is a parallelogram. Let's see, what else do they give me? They give us that BF is perpendicular to AFD. It's an F, in case you're wondering. And DE is perpendicular to BEC. Those are all of our givens. Now, depending on how your teacher does it, they might say, you know, use one given at a time, and that's okay. Everybody does this different. It's fine as long as you get to the same conclusion, right? So ABCD is a parallelogram. I'm going to use that first. That means that this side is parallel to this side, and that this side is parallel to this side. Yeah? So AEC, well, I guess BC is parallel to AD, and AB is parallel to CD. Opposite sides of a parallelogram are parallel. Okay. Hooray. Which means that BE is parallel to FD. Parts of parallel lines are parallel. Duh. Right? You feel kind of silly for saying that. I understand. Okay, so then what else did I do? BF. Oh. BF is parallel to ED. Because two lines perpendicular to two parallel lines are also parallel. Oh, I just said it how my college professor says it. Parallel. She always emphasized a different part of the word parallel. Parallel. It's funny. She's great also. Okay, so that means that BEFD, oh, where am I? I'm having a hard time with this. So that means that BEDF, sorry, I said that wrong, is a parallelogram in a parallelogram opposite sides are parallel. Okay. So then we can say angle F, so let's see, angle BFD is a right angle, which, you know, is a big deal. Perpendicular lines form right angles. Sorry about my spacing there. So 7 BEDF then is a rectangle. A parallelogram, with one right angle is a rectangle. Okay. Again, I want to say that's not the only way to do it. If you wanted to get these two triangles congruent, so you could easily do that, like angle A, angle C. Get these two triangles congruent. One pair of sides parallel, the other pair congruent. Using that, you can then turn this into a rectangle kind of in the same fashion, using corresponding parts of a congruent triangle are congruent. So angle, angle, side, corresponding parts. 4 sides, 4 angles. You could say 4 right angles, so that's obviously a rectangle. You could get to that. What else did people do here? There's all kinds of ways to get there. That's probably the fastest way to get there, is those 7 steps. So hopefully you understand what I just did and you found this helpful, and we will see you again soon. Thanks for playing.